Welcome back to Daily Math Concepts, and today what we want to look at is the trig ratios, right? We want to look at the trig ratios. So the trigonometric ratios are such that if you have an angle and a side, then definitely you will be able to solve a triangle, that is a right angle triangle, that is. Before we actually step into using the trig ratios, we want to understand a few things. One, this word opposite. We want to know the opposite sides to angles. We want to know the adjacent side to angles, and we also want to look at the most important thing, the hypotenuse, which we will not try to confuse with any of these. All right. So what is the hypotenuse? Well, definitely the hypotenuse is that longest side of a right angle triangle, and it is across from the 90 degrees. So imagine if I stand where the 90 degrees is with a I would say a water hose that has a lot of pressure. If I start to spray it, it's going to go across there. So that side that it touches across from the 90 degrees is what we call the hypotenuse. So here it is. The hypotenuse is sort of an independent side that does not mingle with the others. So it doesn't matter how the triangle turn, for example. So even if my triangle turn in various ways, the concept of the hypotenuse does not change. So let me stop it. So the hypotenuse is such that it's going to be across from that right angle, across from the right angle, across from the right angle is the hypotenuse. So let's keep turning our right triangle here. So if I try to turn this and I turn it this way, then all I want to do is to identify the right angle, which is the 90 degrees. And if I go across from the 90 degrees, I will touch the hypotenuse. So the hypotenuse is that side across from the 90 degrees. And we want to establish that first. Now, as matters relate to the opposite or the adjacent side, they are conditional to the angles. For example, let us consider the angle B. So we're considering this angle at B. Now, the hypotenuse is always going to be across from the 90 degrees. So the hypotenuse is not anything that we want to mix up with the other things. But the opposite side is across from the angle in question. So this angle B, if you go across from angle B, then you would have an opposite side to angle B. So this side is opposite to angle B. But on the same time, if we look carefully, there is another side here. This side that helps to form the angle at B, and we're not referring to the hypotenuse. This side that helps to form the angle, which is different from the hypotenuse, is always the adjacent side. The word adjacent would refer to beside. It means helps to form a margin and stuff like that. So here is the thing. We're saying then that the adjacent side helps to form the angle that we're talking about, while the opposite side is way across from the angle. Let's take off these labels. So if I should rotate this triangle, like that and stop, if I consider the angle at A, then any side that is across from, that means if I stand at the angle A and spray across, this is the opposite side to angle A. And at the same time, apart from the hypotenuse, the other side that helps to form the angle we're talking about, this side is the adjacent to angle A. So we're referring to those words. And as long as we're able to pick up the adjacent differently from the opposite, differently from the hypotenuse, then we're ready to go with solving triangles, the trig ratio. All right. Let me just reiterate an idea. All right. So just to reiterate an idea quickly. B, C. All right, so if we call this ABC, then let's mark an angle. We could mark an angle. We could call this, so this, I could just call this angle, anything. I could call this angle little b. I just want to call it angle little b. All right, so we have an angle there, and we have an angle right here. So let us call this angle little c. Okay. Now, for these angles that we have here, they all have their own opposite and they have their own adjacent, but the hypotenuse is none of theirs. So the hypotenuse is always the longest side. It is across from the 90 degrees. So this is the hypotenuse. The opposite and the adjacent sides could go anywhere depending on the angle we're speaking to. For example, let me put some numbers on these for labeling sake. So if this is number 2 and this is number 3, we could say here that number 2 is opposite. So side 2 is opposite to angle B. So side 2 is opposite to angle B. So we're talking about side 2 opposite to angle B here. And you can see that it's across from it. So yes, it is opposite. It's a cross from it. All right, good. Now we could look also and we'll notice that angle, or we could say side 3 is opposite to angle C. Watch, across from it. So definitely it is opposite to it. So we could say side 3 is opposite to angle C. The thing is, you could see that opposite sides are relative to an angle. All right. So it's not like a side is opposite all the way. It is conditional to the angle. Now, these same sides here that are opposite, we could show you in instances where they are adjacent. For example, this. I could say that side 3 is adjacent to angle B. And you could see it helps to form the angle. It's next door to the point where if I should remove side 3, look for yourself. There is no angle there anymore. If I should remove the side, let's put it back. If I should remove side 3, the angle that it is adjacent to is no longer there because the triangle would no longer exist. Let's put it back. That's what we mean by adjacent, right? Next door. And let us look at this same idea. We could say that side 2 is adjacent to angle C. Now, take it off. It's gone. So the angle does not exist right here. Let's put it back. Now we have the angle. Let's remove it. We don't have an angle. Because it is adjacent, it helps to form the angle. And we're not referring to the hypotenuse. That's different. All right. So there we go. So what we're saying is adjacent refers to beside, next door. It means the margin, and it helps to form the angle. We could look at opposite as in something that does not help to form the angle. For example, look at this case up here, 2, where we say angle 2, we say side 2 is opposite to angle B. So so opposite is across from. So we want to look on that idea, across from. Let's take it off. When you take off an opposite side, the angle still exists. So look at B. The angle is still at B. Let me put back the side. That's an opposite side, because if I take off an opposite side, the angle is still there. So these are some of the things that we can use to memorize what is opposite and so on. But remember that opposite speaks to across from, okay? And adjacent is next door. All right, good. How do we use these though to help us to solve? That's the next thing that we want to get into. So the sine, it is said that the sine of the angle at B is equal to the opposite, which is AC. Let me write opposite first. Is the opposite side over the hypotenuse side. And in this case, it is equal to AC over BC. So that's the sine of the angle. That means if I find the sine of this angle, it's going to equal to this side over that side. The cosine of that same angle is equal to the adjacent side over the hypotenuse side. And in this case, we're talking about AB over BC. Thirdly, the tangent of the same angle B is equal to the opposite side over the adjacent side. And what we're referring to is AC over AB. And that's pretty much what we're about to go on. How do we use these to help us to solve these triangles? So we're going to look on how do we use what many call SOH CAH TOA, right? So it's a catchy phrase that we have been using all our lives, going to schools. How do we use this to solve triangles? Remember now that the S refers to sine, the C is cosine, and the T is for tangent. So just in case you don't know, I'm putting it there. The sine of an angle is the opposite over the hypotenuse. There it is. The cosine of an angle is the adjacent over the hypotenuse. The tangent of an angle is the opposite over the adjacent. With this, we can solve many triangles. Let us say that we have a case now, right? Degrees. Now, what we have is that we have X that we intend to find and 10 that we have here. Well, let us say it's 10 meters. Let me put on the unit. So then what we want to do then is to make sure that we have our, so we're saying now, what do we have? So we're going to be looking to see what information we have right now. Now for this angle, we have an adjacent side, which is next door. And they ask us to find the hypotenuse. The hypotenuse is across from the 90-degree angle. All right. So here is the thing though. All right. So hypotenuse is across from the 90-degree angle. All right. So which one of these would have the hypotenuse and the adjacent? Cosine. So it means then I'm going to use this cosine ratio. That says the cosine of an angle is equal to the adjacent side over the hypotenuse side. Those are the things that we have in question, right? So because those are the things that we have in question, we're talking about the cost. So the thing surrounding this situation is that we have the adjacent side to this angle, and we have the hypotenuse side. So that is why we picked out the cosine, because it has those things. So now we're going to substitute. So the cosine of 60 degrees is equal to the adjacent side, which is 10, over the hypotenuse, which is x. Or you could just multiply both sides by x. Understand? All right. So what's going to happen? We're going to multiply both sides. We're going to cross multiply. All right. So in cross multiplying, x cos 60 is equal to 1 times 10. If we should divide both sides by cos 60, then we could get our answer that x is equal to 10 divided by the cos of 60. When you put this on our calculator, it's 10 divided by 0.5, and this is going to give us 20 meters. So then this is suggesting to us that this side that we're looking at here, x is actually 20 meters long. So what we're saying, we're able to utilize these cosine and sine, the trig ratios, to solve a right angle triangle. All right, let's go again for another. That the sine of an angle is equal to the opposite side over the hypotenuse side. The cosine of the angle is equal to the adjacent side over the hypotenuse, and the tangent of the angle is equal to the opposite over the adjacent side. So let's put in some numbers. So let us say we have a 70 degrees here, and this is a 7.8 meters. Question asks us to find that side AC. Now, when we are asked to find or to solve a triangle, especially a right triangle, we want to make sure that we identify what we have and what they want. So what we have is a 70 degrees. We do have 7.8 meters, and we were asked to find AC, which is x, right? All right, let's see how far this goes. All right, let's see. Now, let's go. All right, so we have to now identify what do we have. How is this 7.8 related to the 70? It's across from it, therefore it is the opposite side to 70 degrees. The side that they asked us to find is x and is adjacent to this 70 degrees. So we're looking for the trig ratios with one, the opposite and the adjacent in it, number 2. So tangent is what works. Here it is. So we're going to be taking the tangent. We're going to write what it is. The definition, tangent of an angle in the right angle triangle is equal to the opposite side divided by the adjacent side. Now let's go on to substitute what we do know. We do know that we have the angle. So the tangent of 70 degrees is going to equal to the opposite side, which is 7.8. And that is going to be divided by the adjacent, which is x. We intend to find a value for x. We could do a quick cross multiplication. Let's put this tan 70 over 1. If we cross multiply, we would have x tangent of 70 degrees is equal to 1 times 7.8. So here it is now that we intend to find this x here. So all we're going to have to do is to divide both sides x is equal to, and let's work that out. We're talking about 7.8, and we want to divide that by the tangent of 70 degrees, and we do get 2.84 to 2 decimal places, right? 2.84 meters, and that's the answer. So what this is suggesting is that this side x is 2.84. Let's say that we have triangle that, and we have, say, 65 degrees here, and we have this, which is 25, centimeters, and we were asked to find AC is X. Again, we have to identify what we have. So let us look on what we have. We do have an angle here, which is 65 degrees, yeah? And we were asked to find X, which is across from it. So you could say this is the opposite. And we have the hypotenuse, which is the independent side. It does not mix. So then let us just write down what we have. This is the hypotenuse, and this is the opposite. So we're going to look back at our trig ratios to see which one of these trig ratios would have all of these together. Sine. The sine is the one with the opposite and the hypotenuse. Here it is, the O for opposite and the H for hypotenuse. So then we can write the formula that says the sine of an angle in a right angle triangle is equal to the opposite side over the hypotenuse side. Now let's go on to do some substitution. The sine of 65 degrees is equal to the opposite side this time, which is X over the hypotenuse, which is 25. Then again, we can cross multiply if we want, whatever means that we find, that's fine. So if we cross multiply, we would have 25 times the sine of 65 degrees is equal to 1 times X, which is just X, all right? Now let's put this to work. 25 sine 65, and make sure that the calculator is in degree, will give us 22.66 to 2 decimal places, and that's centimeters, and that is equal to X. What are we saying? We're saying that the value of X here right now is 22.66 centimeters. All right. Now, sometimes you may not be asked to find a side because a lot of times you will be asked to find an angle. So I'm suggesting that let's look on a case that we're asked to find an angle. How do we treat it? What different things would we do? All right, let's check this out. We're dealing with 22.66 here. And we want to find that angle up there. We already know that the angle is 65 degrees. The angle, and we have these two sides right now. How do we go about doing that? The procedure remains the same. First thing we want to do is to identify what we have. So we have this angle right here. We have that angle right there. And when we say have, we're still referring to what they're asking you to find. That is a part of the game right now. So then you look across from this. You're like, oh, we have an opposite side and we have the hypotenuse side. So we have all of these variables. Which one of these ratio would have the opposite, as you could see, and the hypotenuse? Let's pull down right there. It's the sine. So we're using the same sine of the angle, which is equal to the opposite side over the hypotenuse side. Now, the sine of the angle, we don't know the sine of the angle. We don't know, all right? But it is equal to 22.66, which is the opposite side to that angle, over the hypotenuse, which is 25. Now, let's work this down to see what it is. So let's get a value. 22.66 divided by 25. That is equal to 0.9064. All right. Now, the thing is, the sine of the angle is equal to this. This is not the answer. It's the sine of the angle that is equal to this. So this is what we're going to do now. We're going to have to do what is called the arc sine, or what is called the sine inverse. So we're going to activate the second function of the shift on our calculator to get this symbol coming out. And then we're going to place the value for the angle right here. And it's going to tell us what the angle is. So we're going to bring that up. We're going to bring that up. We're going to bring up shift, sine, and it's going to come up. And then we're going to put 0.9064. And I get 65.0 to 1 dp as the angle, which is just 65 degrees. We already knew it was 65, but we're just showing that if we're going to solve and we have an angle to be found, then that's the approach. Let's look at another case. Trying to find the angle using the trig ratios. Let's say our triangle looks like that. So let us say we intend to find this angle. I do have this, which is 12 centimeters, and I do have this, which is, say, maybe 17 centimeters. Now, we want to find this angle. So let us go about labeling our angle right about now. So that's the angle that we want to find. What do we have, though? Across from the right angle, we know that this is the hypotenuse. So we have that. And then the side that helps to form the angle, we have that. So this is the adjacent. So we have the adjacent side, we have the hypotenuse side. Then which one of the trig ratios? Here it is, cosine. So we're talking about the cosine of an angle in a right angle triangle is equal to the adjacent side over the hypotenuse side. Let's go further. My bad. So that's the cosine. Let me rewrite everything. So that's the cosine of the angle that we don't know is going to equal to 12 over 17. So we need to find the value for 12 divided by 17. So let's write this. So the cos of the angle that we're searching for is 0.7059. So this is the value of the angle in a cos, value of cos of the angle. But what we're going to do now, though, is to use up our inverse. So it's going to be the cos inverse, and we put the value of the angle, and it's going to tell us the angle that it came from. So activate your second function or your shift on your calculator, touch cos, and then you'll see that coming up. Put in 0.7059, and we're getting 45.1 degrees to be that angle. So there it is. So that is how we utilize the trig ratios to solve for sides as well as solve for missing angles. Thank you for watching. Please subscribe to Daily Maths Concepts. Look out for more videos. Click the notification bell so that you could receive videos as soon as I upload them. Thank you.